we're doing determinants, and then
What's that?
I'll get there. And
Oh, it's
then
okay.
Friday we'll do like the second half of the section, which is inverses. We might get to some of it today. So a determinant is really just a number that we get from a matrix. You can only get them from square matrices, and we use them to do things. I'm not going to get into what we use them to do things with just yet. So for right now, I'm just going to show you how we're going to find the determinant, and then we'll talk about where we're going to use it later.
Very cool, Miss Rep.
So again, we only can find determinants of square matrices. We will do 2 by 2 and 3 by 3. Because there's no 1 by 1 and 4 by 4, too big. So with the 2 by 2s, you can find a determinant by taking the top left element or number and multiplying it by the bottom right number. So you find that product, and then you subtract this product. Easy enough, right?
Whoa.
You just have to make sure that you go left to right, top to bottom first.
Oh, Emma, can I
Left to right, top to
I don't
bottom.
have a pencil.
Now, there's 2 ways you can write a determinant. You can write it with the DET in front of it,
So nice. These tables are
or you can use straight lines. Both of these are ways that you could write determinant of the matrix. So you can either write DET in front of it, and then just the regular matrix for determinant of this square matrix, or you can put straight brackets instead of like closed in brackets, and both of those mean determinant. So you'll see it switches back and forth just so you get familiar with it. This one says determinant, this one just has the straight lines. They mean the same thing, just 2 different ways of saying it. Okay? Questions about that?
Isn't the straight lines absolute value?
No. Can't find the absolute value of the matrix.
Oh.
Okay, we're not going to do 3 by 3s. I'm going to go do the 2 by 2s, and then we'll go back and talk about the 3 by 3s.
Oh my god, wait, can you go back to the thing with the, like, the lines? The B, like, said, like, equals A.
We'll get there. I'll go back in a second. All right, so first we're going to take the product of 3 and 5. 15. And then we're going to take the product of 2 and -1, which is,
-2.
thank you, and then in between we are going to subtract.
17.
So the determinant of that matrix is 17. What does that mean? We don't care yet, but we will. We're going to do stuff with determinants. Right now we're just finding determinants.
Let's count out.
Okay. All right. See if you can try and see you'll try. Determinants of 3 by 3s. I'm going to show you the diagonal way because it's kind of more in sync with the way we do the 2 by 2s, and then I can show you the other way if we have time. So what we do is we take our 3 by 3 matrix and we rewrite the first 2 columns next to it. So I'm going to rewrite this because if I don't, it's going to look weird. So these letters in here are just representing the numbers in the matrix. So first thing we do is we rewrite column 1 and column 2 next to it. And we're going to take the product.
Oh, that was close.
It's fine. The
Wait, hold
product
on. Let me
of the
realign it.
diagonals going from left to right, top to bottom, one at a time. This product, and this product. That's these 3 things. And then you take the sum of those 3.
Wait, where do you get the AB and then some on the outside again?
I just repeated the first 2 columns next to the matrix.
Okay.
Then you go the other way. Just like with the 2 by 2. You just do it 3 times instead of 1 time. So you do these 3 products, and then you find the sum of those 3
Forget
products,
about B and E.
and then you subtract in between. So it's essentially the same thing that we do for the 2 by 2, you just have more diagonals. So you do this minus this.
Mind me asking, what do you do with that far
Someone
left
might be
B
asking.
and the far right E?
Nothing.
You just leave them B?
Yeah.
I know that this is also, in this situation, since there's only one matrix, when
There's
you,
always only one.
well, because you showed it like to where it was like,
Okay, stop. The first thing you do is repeat the first 2 columns.
oh my bad, I didn't listen that far.
Clearly no one did.
Well, that's why I asked that question, just in case. Okay.
So that allows us to find all of the diagonals. Otherwise, you only have the first diagonal.
Thank you.
So you're going to use diagonals to find products. This is 1. 1 times 4 times 3.
12.
Okay. And we're gonna find the next product.
Oh my god,
30.
you're going so fast.
No, because
Zero.
there's 0.
I'm retarded. Jeez.
And then we're gonna find the last product.
That's
Thank you, Connie.
-6. -6. Now, in between here, we add.
Very cool.
So the first cat scratch.
You go so unbelievably
6.
fast, it like scares me.
I don't. You just
So
need to print the
does
notes
that
and then
only
order just the
apply to a
steps.
3x3?
Yes.
Okay.
Okay, so we go 3 diagonals from left to right, top to bottom. Now we're gonna go the other way. So we have 1 diagonal this way. So 5 times 4 times 3. That's 60. Then we go this way. We get -1 times 6 times 1. It's -6. Then we go 1 more. 3 times 2 times 0 is 0. Then we add them up. And when we add those up, we get 54. And in between, we subtract. So that's going to be -48. So that's the determinant of that matrix.
This is just like weird.
Of determinants is so that we can find inverses. Now, again, an inverse of a matrix doesn't mean anything to you now either. So again, this is just like, we're just doing it for the sake of doing it, but eventually we're going to use them to solve equations. So basically this whole section is like a prerequisite to do like real good stuff, like things that are actually going to be helpful. But for right now, we're just doing it to do it, to practice the skill. Read and stop. So to find the inverse of a matrix, you do 1 over the determinant of the matrix, and then you have to switch some things around. So you switch, so first you do 1 over the determinant of the matrix. You do the determinant first, without anything switched. Then you multiply it by a rearranged matrix in which these two switch places, and these two get their signs switched. That's a switcheroos.
Good old switch around.
So for example, let me just take like a really simple. If this is A, then the inverse of A, first you would do the determinant. So 1 over this product minus this product. So you do first. Then these two would switch places. I should have picked different numbers. Hold on, let me pick different numbers, otherwise it's stupid.
Just do like 1 and 0
1,
or
2, 3,
something.
and 4.
I'll do 1, 2, 3, 4. Okay, let's try that again. So first we would do 1 over the
4
determinant.
minus
So
6. 4
minus 6. Then these two are going to switch places. So 4 is going to go up here, 1's going to go down here.
And then -2
And then these two will switch signs.
Very
I
cool.
want to emphasize the fact that they switch signs. So that means that if it's negative, it's going to go positive, and if it's positive, then it goes negative.
So is the quiz on 12.1 and 12.3?
Yeah.
Is this on the quiz?
So then you would simplify. So this
Yeah.
is equal to -1/2 times all these guys.
I just failed this.
And then you would
You do
multiply
that.
the scalar. So you'd multiply all the numbers within there by -1/2. And you'd get -2, 1,
You'd fail though.
3 over 2, and -1/2. And that would be the inverse of matrix A. And again, we're going to use inverses to solve equations and other things. But for right now, we're just working on how to find the inverse. Okay, we won't find the inverse of a... Okay, so this is A. First thing we're going to do is find the determinant of this. So we're going to multiply. -3 times 3. And 6 times -1. And the determinant is the difference of those. So 1 over that is how we start our inverse. Always start with the determinant. Don't start switching stuff and then find the determinant, or you're going to find the wrong answer. Now, we're going to multiply by the switcheroos of this matrix. So these two guys will switch places. So that means if +3 is in the bottom right, he's now going to be in the top left. If -3 is top left, he's now going to be in the bottom right.
But I hope if the -3 goes on top.
Negative 3 is already there, we're gonna switch these two.
Oh, it just
Give it a
happened to be that the
flipperoo.
1 was the same thing as 1. Like it happened to be the same that the first number was 1 and on top of the.
Oh, this?
Yeah.
Yeah, this is just part of the.
Yeah, that's what I figured.
Then these two switch
Wow.
signs. So if this is a positive 6, it's now gonna turn into a negative 6. And if this is a negative 1, it's now gonna turn into a positive 1. Then we work on simplifying. So negative 9 minus negative 6 is like negative 9 plus 6. That's negative 1/3. Okay, and then we know that this means to take 1/3 of all the elements in there, so this is gonna turn into negative 1, 2, negative 1/3, positive 1. And this is the inverse of A. Now, you can also find the inverse of A on your calculator. In general, in math, a negative 1 exponent means like inverse. With a number, it means the multiplicative inverse. So if we take 1/2, the multiplicative inverse is 2. It means to like invert, like actually invert. But we did functions a long time ago, and we wrote the inverse like this. Do you remember doing that?
Mm-hmm.
So it's just a general notation for inverse is to put a negative 1 exponent. Now that's how you would do it on the calculator. So to find the inverse on your calculator, you would create the matrix that you want to find the inverse of. So you create a 2x2 matrix. I don't know if this is gonna work, but I'll try it out. And then you'd put in your numbers. And then you're gonna raise that to the negative 1 power. So like caret negative 1 and then hit enter and you should get this guy.
Hold on. So we took
Worse.